Hello, so we are going to be doing exponential families. If you've seen my other video, normal distribution, this is the gamma distribution and the same steps apply. So if you need like a basis, you should check out that video fast. But this is gamma distribution into the exponential family. So we shall start by writing the gamma distribution PDF, which is basically a function of alpha and beta. There are different ways of writing this PDF, but I have chosen this version. If you come across the other version, it's just the same steps, slightly different, but the same steps. If you understand this, then it will work. So we want to write it in the exponential family form, which is as shown, a function of theta y minus b theta over a phi plus a function of c. So it's really easy. We're going to try get the mean. We're going to try get the variance. We're going to get the canonical link function. And we are just going to try and figure this out. So hopefully you'll understand. So as in all distributions, we start by finding the log. We're trying to write it in exponential form, and it really helps to take the log of both sides of the function. So when we do that, we get log of f is equals to log into y alpha minus 1 beta alpha to power alpha e minus beta y into bracket, close bracket, minus log the function of alpha. And we can simplify this by removing each power. So we take the log of each statement, and we get alpha minus 1 log y plus alpha log beta minus beta y minus log a function of alpha. I will write that slowly so that you can see everything that I'm doing. I would encourage you to pause the video and try to do this for yourself so that you can see how the math works. But it's basically algebra, not anything too difficult. So I'm just going to write that down again to make it more clear. So we have log f on the left side is equals to alpha minus 1 log y plus alpha log beta minus beta y minus log a function of alpha. Pretty simple, right? Okay, so the second step is to find the exponential. Remember, we're trying to make it look like the exponential family. So exponential of a log is just the number f. So the function f is equals to exponential, and we'll put everything that we had before into exponential. So it's just exponential into bracket the function that we had previously, as you can see from what I'm writing. There we go. And then we really want to make it look like the exponential. So I'm just going to rewrite that to make sure everything is clear. And I want to rearrange, so I'm going to bring beta y to the front, and I will put like terms together. So it will be exponential is equals to minus beta y plus alpha log beta plus alpha minus 1 log y minus log the function of alpha. So I am putting like terms together in order to make it simpler, and I'm going to divide by alpha because I'm trying to make it look like the exponential family. So when I divide by alpha, I get exponential minus beta y over alpha plus log beta over 1 minus alpha plus alpha minus 1 log y minus log a function of alpha. So I would encourage you to take this really slowly to understand what's happening. And I want to remove that negative because it's not supposed to be there. So I will divide everything by negative 1, and I get exponential beta y divided by alpha minus log beta divided by negative 1 over alpha plus alpha minus 1 log y minus log a function of alpha. Okay, so that kind of looks like the exponential family if you pause the video and just look at it really closely. So I'll try and equate the two together to kind of make sense of it. So here's what I'm going to do. I'm going to say that theta is equals to beta over alpha, and a of phi is equals to negative 1 over alpha. And let's suppose that just phi is equals to 1 over alpha. It makes sense that way. And therefore, we can rearrange that and write beta is equals to theta times alpha. And we can say that if you do the algebra, we can also say that beta is equals to theta over phi. All right, do you see that? And if we take the log of both sides, we say that log beta is equals to log theta minus log phi. So that makes sense algebraically. So we can rewrite the above expression in exponential family form, and therefore it is exponential y theta, because theta has taken over b divided by alpha, so y theta minus log of theta, because from above we know that log of b, right, is equals to log of beta is equals to log theta minus log phi. So we can write it as log theta plus log phi divided by phi. And then we can rearrange that other part and get 1 over phi minus 1 log y minus log a function of 1 over phi. So I would encourage you to pause the video and really understand what's happening. Notice that we are substituting a lot of things for the other because we are trying to write the function in terms of phi, and that's the expression that we get. And that is a constant, and we have rewritten it officially as the exponential family. So let's get to the nitty-gritty of things. We will find the mean. So the mean is a fast derivative of b theta. So if we found that b of theta is equals to log theta, then we will find the derivative, which is basically 1 over theta. So that is the mean. And note that the inverse, or rather 1 over theta, which is theta negative 1, is also alpha over beta. We can get the canonical link function, which is b theta is equals to log theta. Therefore, the inverse of b theta is, in terms of mu, is 1 over mu. We can also get the variance function, which is the second derivative of b of theta, which is b prime theta derived again. So it's 1 over phi squared. Take that slowly if you're not understanding how it's being done. And the variance function, which is a of phi times the variance function b double prime of theta, and we get that as theta over phi squared. So basically that is it. I hope you understood. Do take it slowly again if you didn't get it.